Okay, so today we'll be building a chatbot which can read through PDF documents, and then we'll also be demoing it using Gradio. So to get started, we just first install these libraries. I'll be adding the link to this collab notebook in the description below. So we install all these libraries. I've already installed them, and we check the GPU. You need a GPU instance to run this. It will not work on a normal CPU instance. So you can come to here, runtime, and then change runtime type to GPU. If you have A100 or V100, that's better, but I'm using the free version, so there's nothing that you need extra to run this. You log in into Hugging Face Hub. You log in because you need the Hugging Face Hub access to access the Llama models, Llama 2 models, and also request the Llama 2 models if you don't have access to them already. Again, we won't be using any open API keys, so this is all using open source LLMs. Uh, we need NLTK, and then first we load the Llama 2 7 billion chat model. So I've already loaded it. It takes a little bit of time, so I've run the code beforehand. So I am loading it in 4-bit state. It just makes that the GPU requirements are lower for this, and you have enough space to load the context and all of those into GPU memory. So you have the bits and byte config. We are loading it in 4-bit, the model ID, the tokenizer, and the model with the quantization config added to it. As you can see, it takes around 5 gigs of memory. Then you uh, create the prompt template. You need these tokens as the Facebook website says for the meta research page says it's like you need the instruction token, the system tokens, and that's why you get this is a helper function to create the prompt. Then you download Hugging Face embeddings. This is to create the embeddings, which will which through which your documents are stored in a vector storage uh, for retrieval later. And we have the recursive character text splitter, the Chroma vector store, and the PDF loader. We for the toy example, we are using the World Chess Championship 2023 match between Ding Liren and Llama2 because this is quite recent, and I don't think the Llama models were trained on this one. So we'll be using this as the context for our questions. Uh, we are using a text splitter, recursive character text splitter with a smaller chunk size and a chunk overlap of 20. We are using this because we don't want the GPU, the queued out of memory error. So because all of the documents that you pass as context also go into the GPU memory. So we are using a small chunk size. If you have a larger machine, you can increase the chunk size here. We load the pages, we create the embeddings into a database, and we are using a persist directory because in case you have a lot of documents, you don't want to do this over and over again. You want to store it somewhere and then call it directly. Okay, now is the instruction given the context that has been provided. The context will be passed here. Answer the following question. The system prompt is that you are an expert in chess. You will be given a context to answer from. Be precise in your answer wherever possible, and then if there are any sources, cite those sources. As you can see, our helper function creates the prompt with the instruction along with the sys tokens already. Then we set up the LangChain. We set up the Hugging Face pipeline because we want to use that to create the LLM, and we get the prompt template, the retrieval QA. This is actually not required, so uh, uh, just remove it. I don't think we need it. We need this anywhere. And then the conversational retrieval chain and the buffer memory and the buffer window memory. We'll be using the window memory, but you can also use the conversation buffer memory. This one just loads all the conversation that you had. Here it loads up to a number of conversations that you define. And then this is the template, and this is the prompt. We will be loading the last 5 conversations that we had. I don't think we'll be needing more than that for this demo. So, and then we define our retriever, and then we create the pipeline, which is the Hugging Face pipeline. So, pipeline text generation model tokenizer, max new tokens is part of this function, so we can change it whenever we require. And then we create the ChessBot class. So this is just to help me make any changes as I wish. You, if you want, you don't need to create a class to create the chatbot. But here we initialize the memory, the prompt, and the retriever, and then we create a function that helps us create the chatbot. We define the Hugging Face pipeline, the LLM, and the chatbot itself, which is the conversational retrieval chain from LangChain. And then we create an instance of the class here, and then we create the bot itself. Here we define two helper functions. So I'll uh, roughly explain why we are creating this helper function. So we want to clear the memory that the bot has in case we feel that the memory is becoming too big. So we want to create a button which, when we press it, it clears the memory. So here is the button, which is the clear memory. And when the clear memory button is clicked, it will execute this function, which is bot.memory.clear. And then also we want to see what happens when we play around with uh, the system prompt and how the LLM behaves. So we want to create a text field where you can pass in your own system prompt and see what happens. So we have a text field as well as update system prompt. And when you hit enter on the update system prompt, when you pass something, so and if it is not empty, then what we want to do is we want to update the prompt within the bot using the template provided. So we are not using the chat interface from Gradio because I think it doesn't provide you that much flexibility than using just the blocks. So we're using the Gradio blocks. Here is the text box to update the system prompt. Here's the chatbot box. This is not the chatbot itself, it's called the bot. The message where you will be passing your question. The clear, it clears the messages, previous messages. Clear memory clears the memory of the bot. And then the respond functions actually is passed whenever you hit the message, enter on the message button. So it gets the answer, it appends the chat history, and then returns the chat history. So the chat history is the one which the Gradio remembers and then shows you in the space. All right, and we'll launch the demo. We'll have debug is equals to true and share is equals to false because we want to see what errors come when it happens. So as you can see, we have the update system prompt space, the bot itself, and the question. So we want to ask who won the chess world chess championship in 2023. And as soon as I hit enter, it will try to load in the context using the retrieval, and then it will pass through the LLM, and then it will try to come with an answer. We have told it that it has to be as precise as possible. So let's see if it is precise. Yeah, it is. So it returned based on the information provided in the text. The winner of the World Chess Championship in 2023 is Team Liren. Now let's see. We'll ask it to act like a drunken man. So act like a drunk person. So your responses should have spelling mistakes. So we have updated the system prompt, and let's see what was the final score and did the match go into tie breaks. We know that the match went to tie breaks, so let's see if our chatbot is able to answer it also in a particular flavor, which is of that of a drunk person. One more thing to remember that we are not using any API, so you can run this on your local machine as well. You don't even need internet access to run this. Uh, Apart from the Gradio, I think for Gradio, you don't need internet access as far as I remember. There's also some things that you can do, which is like streaming and stuff like that. So uh, you can stream the responses so that it feels that the time is not taking so long. But and also I haven't set this up so that the inferencing time is super fast. So it will take some time, but okay. Clearly it has broken. World Chess Championship win 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 win. Okay, let's ask you a different question. What was the result of the first game? As far as I remember, the first game was a draw. Let me just confirm again. Okay, now it has replied, and as you can see, it has some flavor of a drunk person, but yeah, what hiccup obliques, the result of the first game was a 49 move draw. I think that's correct. The first game was a draw. So I think it works well. So this is how you can create a working demo of a chatbot which can go through your own documents and provide reasonably good answers uh, on just Google Colab. It means that you don't need that much hardware, and you also don't need OpenAPI, uh, OpenAI API to run things. All right. Thanks for watching, and do like and subscribe. Also, let me know in the comments if you want any more large language model related tutorials or anything that you want me to cover. All right. Thanks for watching.